Okay, objective 2. So now we're going to look at this idea of being statistically or statistical significance. All right. So it says, note, before making any firm conclusions, we must account for the possible differences in response that could occur only due to the random assignment of treatments. Okay. So again, when you randomly assign your people to the treatment groups, random assignment's not perfect. So say I have boys and girls, right? I give each boy a number, each girl a number, and I randomly assign them. It could happen that one group gets all the boys and one group gets all the girls. It could happen. Is it likely? Not likely that every boy would be in one group and every girl would be in another group, but it's not impossible. So in that case, that could be, an issue due to the random assignment of treatments. And again, that is, we make sure that the difference in the response for the groups in an experiment is larger than what we could expect to occur due to chance variation in the random assignment. Again, this is a very important sentence. We must make sure that the difference in response for the groups in an experiment is larger than what we would expect to occur simply due to chance variation in the random assignment, simply due to how the groups came out. Okay? And again, we have statistically significant results if a result observed between the groups is too large to be explained by chance variation in the random assignment, too large to be due to chance variation in the random assignment. And again, we are looking for statistically significant results because then that is what is going to lead to cause and effect. That's why experiments are very, very key. If we can find statistical significance in the difference between our groups, then we can be on our way towards being uh, being cause and effect. Okay. All right. Cool. So let's take a look at our next problem. So this is in two parts. Part A is on this page, part B is on the next page. How did the doctors do? It says nearly 22,000 doctors were randomly assigned to take aspirin or a placebo every odd numbered day, hoping to find that aspirin helps prevent heart attacks. These doctors were also randomly assigned to take beta carotene or a placebo every even numbered day, hoping to find that beta carotene helps prevent cancer. So there's actually two studies in one. So this is sort of like the breaking point. So again, this is going to be for part A and this is for part B. All right, so part A, it says the proportion of doctors taking aspirin who had a heart attack was smaller than the proportion of doctors taking a placebo who had a heart attack. So again, there's a difference, right? And the difference was statistically significant. Explain what it means that the difference was statistically significant. Quick. So again, this is a memorized answer in context. So what we're going to say is the following. We're going to say the difference in the proportion of doctors who had a heart attack in the two groups So again, notice the word difference because we have two groups, difference. It's a proportion problem. And again, what are we measuring? We're measuring whether they had a heart attack or not. Who had a heart attack? And because there is statistical significance, that means that this difference was too large to be due only to chance variation in the random assignment to treatments. So again, it didn't matter how the groups were broken up. The difference was so significant that despite maybe the differences between the groups, those were negligible. It was, in fact, what we were aiming at, the treatments, aspirin versus the placebo. Okay? So again, it's this idea of can we eliminate all of the chance variation, all the other differences between the two groups, and focus solely on the treatment? Okay. All right. Part B. It says, okay, nearly same kind of thing. So now it says the difference in the proportion of doctors taking beta carotene who developed cancer and the proportion of doctors taking a placebo who developed cancer was not statistically significant. Okay, so the difference was not statistically significant. Explain what it means that the difference was not statistically significant. So now it says the difference in the proportion of doctors. So again, in the proportion, it's a proportion problem, of doctors who developed cancer. So again, what are we measuring? If we developed cancer or not? Developed cancer. In the two groups was small enough. So again, instead of saying was not large enough, we're going to say it was small enough that it could be due to chance variation in the random assignment to treatments. So again, this statistical significant kind of problem is the same thing as the convincing evidence type of problems. And again, notice we say was small enough that it could be due. We're not saying that it is due just to the random assignment, that it's these other things that are getting in the way and not the beta carotene and the placebo. We're just saying that this did not provide us enough evidence to support that claim. Right? So maybe further testing needs to go on. But right now, we cannot say that taking the beta carotene causes less cancer than not taking it. Okay. All right, good. So hopefully that makes sense. Again, you're going to use that throughout the rest of this chapter and moving forward in terms of statistical significance. All right, objective 2 is done. Objective 3 is coming.